Yeah, I know, right? So we're going to do rational exponents today. So we talked about just some basic properties of exponents, and we talked very briefly yesterday about rational exponents. So we did a little bit of stuff with rational expressions, but let's remind ourselves. If I do x to the 1/3 times x to the 1/3 times x to the 1/3, what's another way I can write that? It's the same as what? It would be the same as x to the 1/3 to what power? Yep. But we would add those exponents, right? And what is 1/3 plus 1/3 plus 1/3? 1. So it's the same as x to the first, right? So because of that, we can say that x to the power of 1 over n is the same as the nth root of x. Okay? Now, depending upon what n is, that also requires us to think about our inputs and what we're plugging in, right? So when it comes to time to take like a certain root of a number, we can only take the root of what type of like negative numbers. What does our root have to be if we have a negative number inside of our root? It'd have to be an odd root if I have a negative number inside of there, right? So that's something that I need to keep in mind, okay? So if n is even, then x is going to have to be greater than or equal to 0, okay? If n is odd, fair game. Okay? All right. Now, we're going to have to, this is going to be a good like mental exercise to see how well we know like powers of 2s and 3s and 4s. So first one, 64 to the 1/3 power. That'd be the same as the cubed root of 64. Is 64 a perfect cube? What is it? 4. 4 times 4 times 4 does indeed give me 64. I bet you guys probably know these better than I do, honestly. All right, what about 16 to the 1/4? That's the same as what? 4 through to 16? Is that a perfect quartic? What would that be? 2, right? 2 to the 4th is 16. Okay. Ooh. Now we have 243 to the negative 1/5 power. So there's a couple things going on here. First of all, I don't like that negative is there. What can I do with that? How can I handle that negative exponent? Okay. So we could do 1 over 243 to the 1/5 power. So toss that term in the denominator and make it a positive exponent. Okay, so now we are going to assume that if I multiply a number by itself 5 times, I get 243, right? Because then that would be the 5th root of 243. I don't write well when I stand up. I'm just going to have to sit down. It just doesn't look good. I'm going to sit in the back. All right, what number would multiply by itself 5 times to equal 243? You guys tell me. Go ahead. I'm assuming it's 3, right? It's the only one that makes sense to me. So 1/3 is going to be your answer. Okay? All right, cool. Okay. Now, there's a couple ways we can deal with what we have next. So we just did like a numerator of 1, but what happens when our numerator is of my exponent is something other than 1. So what's another way that I can rewrite x to the 3/2 power? What is that, Michael?
Square root of x.
Same thing as the square root of x cubed, right? I don't have to put the 2 there, but I will just for illustrative purposes. But at the same time, x to the 2/3 is also equivalent to what? What to the 1/2 power? X cubed to the 1/2 power. And now here's the nice thing. When we're evaluating, we can write it either way, and whichever way benefits us the most is how we are going to write it, okay? So x to the power of m over n is the same as the nth root of x to the m power, which is what I want to do to you guys. I want to empower you to do well. I'm just kidding. That was actually a joke that I stole from Mrs. G. So
I remember that joke.
it's a good one, isn't it? Yeah, I thought it was a good one too. Okay. She's got jokes. The other way that you could think about this is it is the nth root of x to the mth power. Okay, so that's another way you can think about it as well too. All right, so whatever way is more conducive for us to do is the method that we'll use to rewrite it. Okay. All right, so let's do some simplification of those. So n to the 3/2 power. Okay. All right, so we need to think of a way that we can rewrite this that makes the most sense for us, okay? So would it be more helpful for us to write it as the square root of 9 cubed, or would it be more helpful for us to write it as the square root of 9 quantity cubed? Which one would you want to do first, the square root or the cube?
Square root.
Square root, you think? Because we can take the square root of 9, right? So this is the same thing as the square root of 9 to the 3rd power, but I know what the square root of 9 is, so it benefits me to do that first. Square root of 9 is going to give me 3 cubed is?
27.
Very good, 27. Okay, speaking of 27, we have 27 to the negative 2/3. Okay, I'm going to deal with the negative exponent straight away, and I'm going to make this 1 over 27 to the 2/3 power. And now you guys tell me, would you want to square 27 first, or would you want to take the cube root of 27 first? I would say cube root. I don't know what 27 squared is. So 1 over the cubed root of 27, and then whatever that is, we're going to square it. All right, cube root of 27 gives us 3 squared.
9.
Hey. Oh, now we're playing with decimals. Oh, baby. All right, so we have 0.008 to the 4/3 power. Okay, so now we got to remember when we multiply decimals by each other, what happens? If I multiply a decimal less than 1 by a decimal less than 1, does my number get bigger or smaller? Smaller. All right. Well, so is it going to make more sense for me to take the 0.008 to the 4th power or the cubed root of 0.008? I would say cubed root, right? Okay. So I'm going to rewrite this as the cubed root of 0.008 and then to the 4th power. What would be the cubed root of 0.008? Charlie? Close. You had an extra 0. It should be 0.02. 0.02 is what we're going to get. And then to the 4th power. Am I doing that right? Is it 0.02 or is it 0.2? Now Isabel has me second guessing myself. It might just be 0.2. Because if I did it in reverse and I do 0.2 times 0.2 times 0.2, I'd be 3 instances behind the decimal. So Isabel, you're right. It is 0.2. My bad. 0.2. Now I got to take that to the 4th power. Oh my gosh. All right, well, the good news is we know what 2 to the 4th power is, right? 16. How many zeros are we going to have there? 1, 2, 3, and then 16. Good. All right. Okay, cool. Let's do some more. Let's involve some of the properties that we had yesterday into what we are doing today. All right, 2n to the 1/3 power times n to the 2/3 plus n to the negative 1/3 power. All right. What do you guys want to start by doing? What should we do? What do you think? Is there anything I can do inside that parentheses?
We can simplify each n's exponents.
Inside the parentheses?
Yeah.
By doing what?
You can make it like 1 over n, or cube root of n.
Yeah, I could do that, right? 1 over cubed root of n. But there's nothing I could do to really bring those terms together, right? No, because they're not like terms. So what I would do is I would just distribute what's on the outside and then multiply it by each term on the inside. So let's take 2n to the 1/3 power and multiply it by each term on the inside. And let's see what we get. I don't like being back there. I feel too far away. Okay, so my first term, nothing with my 2 to interact with, so I'm going to have 2. And then what do I do to my exponents? I add them. So n to the 1/3 plus n to the 2/3 is going to give me what? Oh my gosh, it's just n to the first, isn't it? Okay, all right, cool. And then my second term, 2n. What happens when I do 1/3 plus negative 1/3? Oh, so what happens there? It turns into 1, so that term is just going to turn into 2, right? So I just get 2n plus 1. I'm sorry, 2n plus 2. Cool. All right, next one. 25 to the negative 1/3 power raised to the power of negative 2/3. Charlie, what's up? Or negative 3/2, right? Okay. Sure? All right. Now what? What should I do for my next example?
Under 1.
Okay, we could do that. We could put it under 1. But honestly, what I would do, what am I going to do with those exponents? I'm going to multiply them. So because of that, my negative and negative is going to multiply, and it's going to be positive. So I would just go right into it. So then in that case, 25 is going to be raised to what power? It'd be 1/2, right? Because it would be positive 3 up top, and then positive 6 in the bottom. So, ooh, what's the square root of 25? That worked out pretty nicely. Okay. All right. I think we got to step the difficulty up a little bit. Let's solve some equations. We did some stuff. I can't remember how much of this you guys had in your homework yesterday, but we did a couple of examples like this in class yesterday where if we have two terms that are equal to each other, they've got different bases clearly, but if we can get the bases to be the same, then we can set the exponents equal to each other. So what I'm going to try to do now is try to look for a commonality between the two bases that I have, okay? All right, so I see like if I'm comparing 9 and 27, what would be a common base between 9 and 27? 3, right? Because I can write 9 as 3 squared. I can write 27 as 3 to the 3rd power. So let's start by doing that. 3 squared, and then raised to the exponent of x plus 1 is going to equal, okay, so we said 27 was 3 cubed, but that's inside of the square root, right? But what's the other way I can write that instead? 1/2. Okay. So then if I do a scant amount of simplifying here, I would multiply the 2 by the x plus 1, so I'd get 3 to the 2x plus 2 equals, all right, and then 3 to the 3rd raised to the 1/2 power would be 3 to the 3/2. Okay? Now, do you guys remember what the graph of 3 to the x looks like from Algebra 2? Roughly? It looks something like this. I don't know. Something like that. Would you say that function is 1-to-1?
Yes.
Yeah. Because of that, I can set these two exponents equal to each other. So because my bases are the same, I can set my two exponents equal to each other. So 2x plus 2 equals 3/2. And I can solve for x. So subtract 2 from both sides. I would get 2x equals negative 1/2. Divide both sides by 2 to give me x equals negative 1/4. I have no domain restrictions with my exponential equations. Like if I look up at my graph, I mean, my domain's going to be all real numbers. So x equaling negative 1/4 is totally fine. I can have a negative exponent. I mean, we've dealt with those before. So, okay. Let's play a similar game for the next one. What's my common base in my next example? 2, right? So 8 I'm going to write as what? 2 cubed. Still have 2x minus 7 up there. What about 1/4? What am I going to do there? 2 to the negative 1/2, right? Good job. So 2 to the, should not write that second set of parentheses, negative 1/2, and then 6 minus x is still hanging out there. Okay, so get your bases to be the same, and then from there, multiply your exponents. So to get 2 to the 6x minus 21 equals 2 to the, let's see, negative 3 plus 1/2 x. Does that sound good? Is that too small for you guys to read up on the board? Do I need to make that bigger? Gideon, you doing okay back there?
Yeah.
Okay. So now my bases are the same, so I can set my exponents equal to each other. You got glasses on anyways. You can probably see for miles, right?
Not really.
All right.
I think it's opposite.
I can confirm that it does mean the opposite. All right. What do you guys want to do? How do you want to solve this? You want to put it on easy mode real quick? What could I do to make this easy? I don't like that fraction.
Multiply by 2.
Yeah, let's multiply everything by 2. So 12x minus 42 equals negative 6 plus x. And then we solve for x. So take x away from both sides, 11x. Add 42 to both sides. I shouldn't do this where I do everything at once, but it is what it is. All right, negative 6 plus 42 is going to give me 36. Okay, so then I would divide by 11 and get a not nice number. 36 over 11. Unless I messed it up. Did I mess anything up?
I think it's supposed to be 2 to the negative 2, not 2 to the negative 1/2. Because it's just 1/4.
Oh, yeah. It's not, it's just 1/4. Right. Okay. It says 2 to the negative second. Oh, that's going to change things a little bit then, isn't it? All right, let me go back and put it in green so you guys can see where I made the mistake. Okay, so then what did we say, 2 to the negative second? Okay, well then that means these terms are going to be different. Oh, sorry everyone. A lot of erasing to do. Okay. Good thing I chose the smallest eraser setting. That's barely any better. All right, let's fix this. Okay, so then in that case, my exponent now is going to become negative 12 plus 2x, which seems a little easier to solve. So negative 12 plus 2x. So then I get 4x equals 9. Yep. So I still get a fraction. X equals 9/4. That's okay. Fractions are all right. Okay, sorry about that. Okay, questions there? You want to know how I knew I made a mistake? Michael busted out that graphing calculator, and as soon as I saw that thing come out, I'm like, I did something wrong. All right, 4x to the 3/2 equals 32. Okay. These are going to be a little different. What do you want to do first? Because now our exponent is a regular number, and our variable is down as a base. I think it's a good place to start. Okay, 32 divided by 4 is going to give me what? 8. Okay, so now I have x to the 3/2 equals 8. All right. I need to get x by itself. How do I get rid of that exponent?
You take the square root of both sides.
Yeah, I could do, well, not square root, but I could square both sides, right? Because that'll get rid of that denominator. And even what I could do, more than just squaring both sides, I would raise both sides to what power? I could actually do 2/3, and then that'll wipe out both pieces of that, okay? So then I would have 8 to the 2/3 as well, too. So x equals, all right. Do I want to do the cube root of 8 first, or do I want to square it? We could. If you square it, what do you get? 64. What's the cube root of 64? 3. So that works out. I would cube it first and get, or take the cube root of it first and get 2, and then 2 squared is 4. Hey, Yeah. Can you tell?
No.
You should.
Is it safe in here?
It is safe in here. This is a safe math place.
Some scary people in here,
I know,
I
right?
want one of those.
It's cool, isn't it? I got this from when I student taught. My mentor teacher gave this to me when I finished my student teaching.
I'm always should give it to me.
What? But it has so much mileage on it.
So rumor has it you may want to come visit.
I was going to send you an email. Yeah.
I'm just telling you that is absolutely fine.
Okay. Not necessarily today, because I know you have a test today, right?
And Mondays are not good either because I'm going over it, which is really boring.
For sure. Yeah, I was going to email you and say, hey,
You let me
seventh
know.
period.
When you're interested, I can tell you which days are good or bad.
You tell me when you have a great lesson. Does he have bad lessons, though?
Oh gosh, yes. They don't even know. She's had me for what, 2 weeks, 3 weeks?
Yeah, okay.
No one in here had me last year, so they don't know.
They don't know. Yeah, I want to come watch you do your
House
thing.
class. I had all of them pretty much.
Yeah.
Last year.
Yep.
I don't know. I'll let them know my physics, so don't ask her.
Okay, will do.
Well, am I close? Although she did okay on her test. Actually did good.
Nice. Good job, Ella. She did good on my test, too.
Nana loves physics. Favorite class she ever had.
She loves pre-calc, too.
Anyway, anytime.
Okay, all right, sounds good. I'll send you an email anyway, though.
Okay.
All right, thank you. Okay, we get x equals 4. I asked my calc kids, I said, if I could, did I ask you guys this as well, too? I told my calc kids that I want to observe a really good teacher in this building, and they said Mr. Shane. So, if you guys have suggestions, I would like to hear your suggestions as well, too. Although, how many of you have had Mr. Shane?
Currently have.
Sure, or currently have. Yeah, just a handful of us. Okay. But they told me he's the guy. And I also heard that from a lot of staff members too. So, yeah, okay. Anyway. All right, next one. Okay, what do you guys want to do first? Add 2. Okay, so then x minus 1 to the negative 1/4 equals 2. Okay. I have a negative exponent. I feel like I want to deal with that. So what should we do? Put that in the denominator, right? Now raised to the 1/4 equals 2. Okay. I don't really like that that's in the denominator. What do you guys want to do to both sides? What can we do here? What do you think? 4th power of both sides? We could do that. I'm still going to have a fraction if I do that. I feel like I'd rather get rid of the fraction. I could take... Okay, well, let's just do both sides of the 4th power. Okay. I'll play your game. 1/4, 4th power. Okay, so then... 4th power on the right side. Well, I'll write it. I'll just write the step anyway. Okay, so then... 1 to the 4th up top is going to give me 1. What about the denominator? It's x minus 1. That's why Isabel wanted to do that. What's the right side going to equal? 16. Now what do I do? I like it. So 1 equals, so multiply both sides by x minus 1. So then I would get 16x minus 16. And then from there, easy money. Add 16 to both sides. Wah. So 17 equals 16x. Divide both sides by 16. I get x equals 17 over 16. Okay. All right. Questions there? Okay. We're marching right along. We've got 5 minutes left. A house now is worth $135,000 and was worth $100,000 5 years ago. What was the average annual rate of appreciation? What letter am I solving for here? R. Okay, so let's plug in our other information. So the pirate problem. We got 135,000 and 100,000. Where do those go? A and P, right? What's A? Yeah. I guess that was one nice thing about buying a house. Hey, what's my T value? I bought my first house like 11 years ago, and so the value's gone up. That's pretty cool. I don't know how long that'll be the case. We'll see. What do I do after that? I need R. R is inside of that set of parentheses. What do you guys want to do next? Divide by 100 large. Okay. All right. 135 divided by 100. I'm just going to leave it like that. Equals 1 plus r to the 5th power. Now what should I do? Fifth root. Oops. Okay, so that's equal to 1 plus r. What's our step after that? Yeah, we're going to end up with some sort of decimal here. So r is equal to the 5th root of 135 divided by 100 minus 1. I would love to know what that is. Isabel's about to pull up her notes app. 0.0619. That sounds like a good answer to me. Anybody verify that answer? My man's got the calculator out. You know he's going after it.
It could be 6, depending on the round.
Sure. Okay.
How do you want us, like, on a test, do you want us to round it or, like, leave it as a radical or?
So if I give you a test, it's going to necessitate you actually, like, plugging that in. I'm going to want you to use decimals at the very last moment, because otherwise you start, like, truncating those decimals. So get it into that expression for r in terms of some value that's not a decimal, and then evaluate it to get the most accurate decimal that you can get. Michael, we good?
Yep.
Okay. All right. 2 minutes left. I got these things. Okay. All right. Let's see how. Okay. Hopefully we can try to. Let's try to at least do one. Okay. So it says factor. So I've got 3 main terms here. So I need to see if there's any commonalities that I can factor out of all of them. What is common betwixt all of those terms? X and y, right? So I'm going to pull out x to some power and then y to some power as well too. Okay, when you pull out a power of x, you do the power that's the least, okay? Because that's the one they all have in common. So it's the furthest left on the number line. Even if it's negative powers, which happens a lot in AP Calc, you guys will see that next year when you all take my class. But you'll see that next year in AP Calc because we pull out the power that's all the way to the left, okay? So then what would be that power for x? X to the what? 1/3. And then what about y? 1/3. Okay, and then we got to play a game of subtraction for all of our terms, okay? So for my first term, I had x to the 2/3. I take away 1/3, so I have x to the 1/3 that survives, right? And then for y, I took out y to the 1/3, so I don't have any y values there left, okay? Minus 7. Okay, so for x, I take out 1/3 from 5/3, leaving me with 4/3. What about my y values? I have 2/3 there. I took out 1/3, so then I have y to the 1/3. Okay, cool. And then for my last value, I'm going to have minus 8 x. Oh, I don't have an x power there, right? Because I factored out x to the 1/3. What about my y value? To the first, because it would be 4/3 minus 1/3 is 3/3. Okay. All right. Sorry, I don't have time to do the last one. You play a similar game. But look, I did the thing. I put it. It's there. It's in your notes. I did it. I remembered. Have a great day. Have a good weekend. Sorry I didn't get to go over your test. I'll find a time to go over it with you guys.
You just, like,
I am expecting we'll probably take a quiz on Tuesday. I'll teach you guys 2, 3 on Monday. We'll probably do a quiz on Tuesday.
could you just, like, cube all?
Maybe Wednesday. No. Here's why. If it was equal to 4 or whatever, then I could cube both sides of the equation.
but you can't.
But since it's just an expression,
Okay.
you can't. It's a good
Okay.
thought, though, for sure. No problem. You guys have an awesome weekend.